Bismillahirrahmanirrahim. Today I wanted to teach you a very important concept, and that is the concept of the geometric mean. Now, to help us understand this concept, first I thought I'd review the concept of the arithmetic mean. You're probably familiar with this because this is commonly known as the average. So if you're given two numbers, the arithmetic mean of those two numbers, let's call it m. M is the mean. So the arithmetic mean of two numbers would be, you just add them together, let's say a plus b, and then you divide by 2. So the arithmetic mean of two numbers, or the average, is just the sum of those two numbers, and then you divide the sum by 2, and that's how you get the arithmetic mean. Now, first we should learn the formula for the geometric mean, and then we should try to understand the concept behind what it means for something to be a geometric mean. The formula for geometric mean is as follows. Let's call G the geometric mean of two numbers. The way you would calculate the geometric mean of two numbers, let's say a and b, first you would multiply them together. And once you've multiplied those two numbers, you would take the square root of the product. So the way you find the geometric mean of those two numbers is first you multiply them, and then you take the product and you take the square root of the product. Now let's take an example. Let's say you're given two numbers, 2 and 8, and then you wanted to calculate the arithmetic mean or the average. That's easy enough. You would say the arithmetic mean or the average is just the sum of those two numbers, 2 plus 8, and then you would divide that by 2. So the average or the arithmetic mean of 2 and 8 is 5. You took them together, you added them together, and divided by 2. Now, if you were to calculate the geometric mean of 2 and 8, the way you would have to do is first you would have to multiply them together. What you would do is you take this as square root of the product, so it's going to be like this. So it's going to be 2 times 8, and then you have to take the square root of the whole thing. So here it is. So 8 times 2 is 16, and the square root of 16 is 4. So the geometric mean of 2 and 8 is 4. The arithmetic mean of the same two numbers is 5, and the geometric mean is 4. Okay, so here we have the formulas. To calculate the average or the arithmetic mean, you just add them up and you divide by 2. To calculate the geometric mean, you multiply the two numbers, and then you take the square root of the 2. Let's do a couple of examples of geometric means before we go on. Let's calculate the geometric mean of these two numbers, 5 and 10. The way you would calculate the geometric mean here would be you take multiply them together, 5 times 10, and then you take the square root of that. So 5 times 10 is 50, and you would have to take the square root of this. Now you can simplify this radical. That's 25 times 2, and 25 is a perfect square, so we can bring that out. So that's 5 times square root of 2. So there you have it. The geometric mean of 5 and 10 is 5 times the square root of 2. Let's do another example. Let's calculate the geometric mean of, let's say, 2 and 5. So the geometric mean is easy enough again. You take them 2 times 5, then you take the square root of that and the square root of 10. And that's really about it. So as you can see, calculating the geometric mean is easy enough. Now, what does the mean really, right? Now, you kind of have an idea what average means. Like, average is kind of like in-between number, right? Now, what does geometric mean? Now, to help us understand this, consider the following. Let's say if we have two numbers, a and b. So let's say this is a, and I'm going to try to draw a line between a and b like this. So if I take two numbers, if you add them together, divide by 2, I get the average or the arithmetic mean, somewhere like this, okay? Another way of expressing that is the distance from a to the midpoint is the same distance from the midpoint to the second point over here to b. So this distance, or the difference from here to here, is the same as this distance from here to here. Now that's what arithmetic mean means. The arithmetic mean, or the average, is a number that's smack in the middle of those two numbers, and the distance between the first number to the mean and from the mean to the second number is the same. In the example that we did, we took 2 and 8, and then we calculated the average of these two. 8 plus 2 is 10 divided by 2, and that was 5. Now the difference from 2 to 5, that's 3. And then from 5 to 8 is also 3. You can visually understand arithmetic mean as a distance or difference between these numbers being the same. So from the first number to the mean, and from the mean to the second number, the distance or the difference is the same. Now, you can actually also conceptualize the geometric mean like this. Now, let's say if you have two numbers, A and B, the geometric mean would be somewhere in between, usually not the same as the arithmetic mean. Let's call that G. Now, the relationship between these three numbers is as follows. From A to G and from G to B, it's not the same distance. It is not the same distance, but it's the same ratio. The same ratio. Now, what does that mean? That means, let's say G is 3 times as big as A. Then B will be 3 times as big as G. Now, if G was, let's say, 5 times as big as A, B would be 5 times as big as G. Like this. So it's the same ratio away. In our example, here we had 2, and then here we had 8, and then we had calculated the geometric mean, and that was 4. So it was like over here, right? Now, what would you have to do to 2 to get to 4? Well, you have to multiply by 2. Now, what would you have to do to 4 to get to 8? Then you have to multiply by 2. Now, as you can see, the ratio is the same. Geometric mean is twice as big as the first number, and the second number is twice as big as the geometric mean. Arithmetic mean is the average of two numbers, and that mean is the same distance from the two numbers. And the geometric mean is the same ratio from each number. Now let's take a look at this in a slightly different way. The same two numbers, you have 2 and 8. The average would be the number that's smack in the middle of it, right? Now, the geometric mean, on the other hand, is a number that's not in the middle, but kind of like equal multiple distance, okay? So let's say this is the geometric mean between 2 and 8. So from 2 to this geometric mean must be the same ratio as from this geometric mean to 2 over here. So we had calculated this as 4, correct? Because then we said from 2 to 4 was times 2, and 4 to 8 was times 2. And that's the geometric mean. Let's do a couple of examples like this, and you'll begin to get the point, I think. Let's try to find the geometric mean of 2 and 18. Now, whatever the geometric mean is, 2 to the geometric mean has to be the same ratio as from geometric mean to the second number. Now, the question is, what is this number over here? From here to here must be the same ratio from here to here. We know the formula, so we can just kind of calculate it out, right? So geometric mean is going to be the square root of 2 times the 18, like this. Well, that's easy enough. That's the square of 2 times 18 is 36, and that is 6. So there we have it. So the geometric mean of 2 and 18 is 6. So let's see if that works out. Well, 2 times 3 is 6, right? And lo and behold, 6 times 3 is 18. The geometric mean. The geometric mean is the same ratio. Now, let's do one more example. Say 5 and 45. Now here again, I want to find the geometric mean so that when I multiply whatever the multiple is over here, from here to here, it's going to be the same multiple. Okay, I'm just going to do the formula here. It's going to be 5 times 45, and then I'm going to have to take the square root of that. It's 225, and the square root of 225 is 15. So the geometric mean here is 15. Okay, 15 divided by 5, so that's 3, right? Okay, 45 divided by 15, that's 3. Aha, so there we have it. Now, let's do the same problem, but at a more theoretical level. So let's say I have two numbers, A and B, and I wanted to calculate the geometric mean between these two numbers. This would be kind of like the geometric mean between those two numbers, and from A to my geometric mean should be the same multiple, and from my geometric mean to B has to be the same multiple. Okay, now in this case, I don't know what the geometric mean is, right? So let's just give it a name. So let's call this geometric mean G. Oh, from A to G has to be the same multiple, and from G to B it has to be the same multiple. Now, what multiple it's going to be? So in this case, for example, if you take 15 and you divide it by 5, I got 3. If we take 6 divided by 2, I got 3, right? So that's the ratio, right, between A and G. So the ratio between A and G, or like this, G over A, that ratio, G over A, has to be the same ratio as between B and G. So B divided by G. So G divided by A has to be the same thing as B divided by G, right? That's how they would have the same ratio. G divided by A has to be the same as B divided by G. See, now you can cross multiply, right? I can solve this by cross multiplying. Now if I cross multiply, I get G times G over here, and that's going to be G squared. Now that's going to be equal to A times B. So if I cross multiply, I get G squared equals A times B. And I can solve this by taking square root of both sides, and then I get G is equal to the square root of A times B. And there we have it. And that is the formula for calculating the geometric mean. And that's the reason why this concept is over here, because geometric mean in a sense is a ratio or a proportion. The proportion from G to A, this proportion right here, is the same proportion between G and B over here, like this. So the ratio here, which is G over A, is the same ratio over here, which is B over G. We'll use the geometric mean in the near future to talk about the geometric mean theorem, one of my favorite theorems in all of geometry. Until then, as-salatu was-salamu ala rasulillah walhamdulillahi rabbil alameen. Assalamu alaikum.